Hi, and welcome to Algebra 1B. Hope you guys are having a spectacular week. I'm missing you guys. I will see you on Wednesday. Remember, you do have Monday off, and you'll get to do this quiz on Tuesday. Alright, so let's start with a little warm-up. We have used several laws of exponents to help us throughout the last 2 units to rewrite quadratic equations. So take a moment here, pause the video. You're going to get to do this as a question and think about this as you're doing this multiplication problem. And we are going to do this as a multiplication problem. I want you to multiply this. Multiplying the x times each thing. Think about it in terms of laws of exponents. Alright, hopefully you've had some time to multiply that if you think about it in terms of laws of exponents. Remember, when we're multiplying things together that have the same base, like an x and an x squared, same base of x, we add the exponents. So x times x squared, that would be x to the 1 plus 2, or third. X times 3x, that would be 3 to the x, 1 plus 1 squared, plus x times 2, which is 2x. So there would be, again, the example of the law of exponents. We use the multiplication law of exponents. We're going to use these same laws to help us rewrite exponential equations. So let's look at those laws we're going to be using. Take a moment to review these. The ones in particular we're going to be using today are this one, this one, this one, this one, and this one. Again, these should be review for you. We've used all of these in the weekly review just a few weeks ago. Did a little review of these exponents. So let's see how we're going to use them. Here is our exponential function form. This is the standard equation for an exponential function. If you remember, the a here always told us our y-intercept, or told us our beginning point. And the b here always told us our growth or decay. And this only works whenever we have something, our b, being raised to just an x. So we're going to see some equations like this one. You'll notice not quite in our standard form. So we need to use our law of exponents to put it into standard form so we can tell those things. So let's look at this here. Alright, whenever we have these exponents, you'll notice we have subtraction here. It's easier to do these problems if you turn this into plus a negative. The old add the opposite. It'll make it much easier on you. So we notice we have addition here between our exponents. If you remember from the law of exponents, we have 2 exponents being added together. It means we're using this law, where we can separate it into 2 different bases being multiplied together. So 2 to the third plus negative 2x, that can be rewritten as 2 to the third times same base 2 to the 2x. I'm sorry, negative 2x. And then 2 to the third, well, that's just 8. And you'll notice we have 2 raised to the negative 2x. That's the same as negative 2 times x. So you have 2 exponents being multiplied together. That's having us use this law. We have 2 things being multiplied together. That's a power to a power. So I can rewrite this as 2 to the negative 2 being raised to the x power. And 2 to the negative 2, that's 1 over 2 squared, or 1/4, being raised to the x power. Alright, so you're going to get to try this as well. Alright, so let's look at another example here, a little bit harder one. We have y equals 2 times 8 to the 1/3 x minus 1. Alright, well, we can write this as 2 times, remember we can change this to plus a negative. So since we have addition here, this is going to be 8 to the 1/3 x times 8 to the negative 1. I'm going to bring my 8 to the negative 1 up front here. 2 times 8 to the negative 1. And then I'll have my 8 to the 1/3 x over here. Just so I can have my a's together. Alright, remember 8 to the negative 1 power is the same as 1/8. So 2 times 1/8, same as 2/8. And we have, again, 8 to the 1/3 times x. So just like before, we can change that into 8 to the 1/3 to the x power, using the old power of a power law. 2/4, that just simplifies to, 2/8, that simplifies to 1/4. 8 to the 1/3 power, if you remember a fractional power, is a 1/3 root. And 8 happens to be a perfect cube. The 1/3 root of 8 is 2. And we can tell from here, our y-intercept is 1/4, and our rate of change is 2. Alright, and this does have a lot of real-world applications. Here is one example. Miss Taylor discovers that her money in this savings account has an annual rate of 4%. Can you determine her monthly interest rate? Well, if you think about it, if it has an interest rate of 4%, that means that Taylor's bank account is increasing by 1.04% every year. So that would be her rate of change, 1.04 raised to the t power. That's her yearly rate. Again, increasing by 4% each year. 1 plus 4%, or 1.04. If we want to change that into a monthly rate, we want to know it would be 12t. So in order to keep this as just a t, it would be 1/12. 1.04 to the 1/12 being raised to the 12t. Remember, using our power of a power, these would cancel each other out. That's why we can separate this like this, because 1/12 times 12 Gus, give us the 1 or the 1t. Alright, well if you pull out your handy dandy calculator, 1.04 being raised to the 1/12 power is approximately 1.0033. We'll round to that. To the 12t. And again, this will tell us our monthly, 12 for monthly, interest rate. So this is how much it increases every month. So if we think about that as an interest rate, we can think about it as 1 plus 0.0033 telling us that this is our monthly interest rate. Taylor's account increases by 0.33% every month. Alright, so you're going to have a practice problem to practice this as well. Quiz questions are very similar to these. We will go over the answers to the document that I uploaded. It's a practice exercise document, a Google Doc. Keep your answers and we will review these on Tuesday. Remember, no school on Monday, and enjoy your nice long weekend. Again, the practice exercises, you'll find it in Unit 2, Lesson 6, in the Try section. Have a great weekend.